what I have on the board?
Yeah.
Yeah, the length of the square root of.
Yeah, it's that squared plus that squared.
Well, you have to find it's not instead of this one.
Okay, you guys, you can't hear her. She's in front of the room. You can't do anything. I didn't think that's a vector going from P to Q. I think that was simply the ordered pair of the point P. Here's the ordered pair of the point Q. I think if you want to discuss this vector PQ, I think you're going to consider a vector whose first component is the difference in these x coordinates. And the difference in the y coordinates. Do you guys agree? Everybody in harmony, do you agree?
Yes.
No, you don't agree because I got to be consistent. I don't care if I mess these two up, as long as I'm consistent everywhere. Technically speaking, I really should start with Q's x-coordinate and subtract from that P's x-coordinate. I did. If I want this to be a directed line segment, particularly with the arrow there. But I think I made a mistake over here. I think the second component has to be, Q's y-coordinate minus P's y-coordinate. I think that really should be -4 minus 1. Okay, I'll be good. No more tricks. But you guys see my point? No kind of thing. What's that? That's true. It doesn't actually not a point. But other points. And so I guess at the end I'm left with. By the way, what's the magnitude of that? I couldn't give it. I'm sorry.
It's root 49 plus root or plus
Is
25.
it? Oh, okay. I was looking at the final answer. So root 59.
74.
I'm sorry. You're right. Cheapers. I can't do it. It's root 74.
Yeah.
I'm arithmetically handicapped every day. If that's the magnitude of PQ, let's ask a whole new question. Give me a vector going the same direction as PQ, bar, whose magnitude is 4.
Just make a unit vector and multiply by 4, right?
Very nice. Because I think right here is a unit vector in the same direction. Hold it, I made a mistake. I meant this. I think this is a unit vector going in the same direction as PQ, bar. When I say unit vector, I mean its magnitude is 1. Now to find a vector that's going in the same direction as PQ, but its magnitude is 4, I'm simply going to take this and multiply by 4. Got scalar form. There is one vector going in the same direction as PQ, whose magnitude is 4. Give me another one. Yeah, if I just change it to a -4, it's a vector going in the same direction, well, opposite direction, but parallel to it, whose magnitude is 4. Do you guys agree? Brad? The question was that silly. Is take your vector, force its magnitude to be 1 by dividing out by its own magnitude, and then multiply the result by whatever scale you want. What does the author say?
Yeah, they just did the same thing, except they put it inside.
Okay, so that's why I'm asking. So your author said, let's bring this in and call this 20h over root 74,
Yeah.
comma, -20 over root. Same thing.
Okay.
If I can write my 4, jeepers.
Okay.
Didn't I turn this on? You guys, if you'll allow me to cheat so I don't have to rewrite this. What kind of document camera is this? Okay, so I do my own.
That is so blurry.
Yeah, that whiteboard has seen better days too.
Need to get some
Whiteboard is fine.
high-proof album.
Hey, you guys, besides that, I'm the one who's oldest, so I cannot do this on my own. You have to help me.
Oh, that's clear. That's clear.
That's good.
It's clear.
Better? Oh, it's a little crooked, isn't it? I'm so bad with these. I'm so sorry.
Still a little
I
off.
can't see the end of the phone.
Yeah.
There we go.
But how about the blurriness?
Blurriness is fine.
Decent? Okay. So number 45 is what I'm looking at. An airplane flies horizontally from east to west at a certain miles per hour, and there's a horizontal wind. Can I draw a picture? So I have to keep rereading this. And if I were to draw myself a nifty little picture, the airplane flies horizontally from east to west at a certain speed of 320 miles per hour. Is that right, miles per hour? It is. And if it flies in a steady 40 mile per hour wind that blows horizontally toward the southwest, well, here's south, the west, it's blowing towards that direction. I guess it's going this way. What was the speed? 40?
Yeah.
By the way, I think I misspoke a little bit. When I said the airplane's traveling east to west at this speed, that means relative to no wind being blown.
Yeah, that's what I was gonna ask, because it says relative to the air, do we go based off the wind speed, or?
And so when the author's saying relative to the air, he really means neglecting any wind, that's how fast the airplane will be traveling relative to an observer on the ground.
Okay.
But now that I introduced the wind, that changes things dramatically. Because now that I introduced wind, I think, relative to the observer on the ground, a vector describing the speed of this aircraft and direction is going to be the green one. Can I give it a name? Can I call it V-bar? And do you think I can do my job correctly if I finish reading the question, which I did not do? Find the speed and direction of the airplane relative to the ground. In other words, I just need to find the magnitude of that vector V, bar, and find its direction. Well, I get so unhappy in a variety of math classes when we pay any attention to vector theory in two-dimensional space. Because I cannot ask you guys a vector question in two-dimensional space that I cannot answer with basic trigonometry and basic geometry. So you guys got to humor me with this. How do you want me to answer this question? Do you want me to be a vector person or a geometry person?
Considering more vector
Vector.
Vector.
You want a vector answer? Here's my vector answer. If I call this vector up here u1 bar, and this one u2 bar, let's see if we can't describe these two vectors. I think u1 bar is a vector with components of negative 320, and it's assumed as measured miles per hour. It's a velocity vector. Comma. You guys there? I heard it on two voices. Did
Yeah.
you see where I'm coming up with this?
Uh-huh. Yes.
As far as the other one's concerned, I said, as far as the other one's concerned, I can't hear you.
It's gonna, you gotta break it into components. You got cosine 45 degrees times. Where do you get the negative 40 from?
I don't know where you're getting it from. Anybody? Negative 20 root 2, comma. Am I in the right place?
How did you get that? How'd you get that?
I got a better idea. Don't listen to me. Let me draw a pretty picture. Whoops.
Just a triangle.
X-axis, Y-axis. Isn't this U2 bar in standard position?
Yeah.
It's just this angle right here has a measure of 225 degrees. And so I think when it comes to U2 bar as a vector with components, how about jeepers, Y and Z. As far as those components are concerned, I think the first one is nothing more than the magnitude of U2 bar times the cosine of that angle in the standard position, which is 225 degrees, comma, the magnitude of U2 bar, the sine of that angle, 225 degrees. Or shall I say the magnitude of this vector is, oh, it's right there, it's just 40. It's just the cosine of 225 degrees from your deep REM sleep is nothing more than, root 2 over 2, but negative. Comma, the same thing for the y coordinate. Oh, but shoot, that's exactly what I have. Now do you believe me? Okay. And if you do believe me, where's my reason? If you do believe me, I haven't answered my darn question. Darn it, negative 20 root 2, I'll put it back in. I guess now as far as a V bar in green is concerned, this is nothing more than the resultant vector, which means I've got the vector with components negative 320 plus and negative 20 root 2, comma, 0 plus and negative 20 root 2. Now, would you guys not agree to find V bar's magnitude is as simple as taking the square root of the sum, the squares of these individual components? Do you guys mind if I don't finish?
Makes sense.
And that would be the corresponding magnitude if you slam it into a calculator. Well, I shouldn't say that. You can come up with the exact value, couldn't you?
Yeah, you could.
Just simplify this in Radican's position. You guys okay with me saying that? Be honest. I don't know most of you. Is it okay me saying you can simplify that by hand? Okay.
Root 2 gets squared.
Okay. All right.
Is it okay to just leave it like that and not simplify it?
Ooh, it gives me the willies. You would never leave an answer in that form. You can clean it up with your math skills. Oh no, I never answered the question fully. Now we need to find the direction of this vector v bar. In other words, sorry, I'm not speaking carefully. I'm trying to rush things. We're trying to find the direction of the airplane relative to the observer on the ground. So I think I need to find the direction which the airplane's traveling. And if you guys want me to play this game of living in vector land, then how would I find the angle?
Tangent.
Very nice. I think the angle theta has a quality that the tangent is nothing more than a ratio of the second component to the first component. Everybody there? And now you can just simply take the inverse tangent of both sides and be done. I said, now you can take the inverse tangent of both sides and be done.
No.
I think the answer is no. I think the inverse tangent of any number is an angle between negative pi halves and positive pi halves. Sorry, we're dealing with degrees, maybe. Between negative, I can't speak degrees, 90 degrees and positive 90 degrees, and shoot, look at this angle in green, it's standard position. Actually, sorry, how about purple? X-axis, Y-axis. I think I want this angle. So it certainly wouldn't be inverse tangent, would it?
You're gonna have to add,
Sir, you've got a good point. If you do take the inverse tangent, that's fine. You get some angle. You're just going to add 180 degrees to it. Actually, do you guys think we can finish this? Can somebody help me with a calculator? What is the inverse tangent of something?
4.64.
You said, I'm sorry, I can't hear that.
4.64.
Is that measured in degrees or radians?
There are degrees.
wow.
And I just lost what you said. I'm sorry.
4.64.
Got it. It's approximately 4 degrees.
Yeah.
What's the answer to the question? How would you answer to somebody outside the math classroom?
Plane is traveling at
4.6
4.6
degrees.
degrees south of
4.6 degrees south of west.
But doesn't this sound awkward? I know what you're saying is correct, but we don't usually go from south to, did you say south to west or west to south?
South of west. But hold on a second. I'm
That
gonna
sounds awkward. I think when you and I typically talk about directions, it's north certain degrees west or east, or south certain number of degrees at west or east. Don't tell me that. What do you say?
4.64 degrees south of west.
Or you could just say heading 274.6.
Okay. I strongly disagree that that's the way people speak outside the math classroom. I think somebody outside the math classroom would have said the direction of the airplane is south of, actually I gotta do some arithmetic. Is that 85.4 degrees west? I think that's how most people would say it. And that way, Linda, I don't have to say this south of business. What if I use the language of heading? What's the heading of this airplane?
274.6 degrees.
Say it again.
Heading is 274.6 degrees.
Wouldn't we?
You see, I think when it comes to the language of heading, don't we usually just rotate in the clockwise direction? That one?
Yeah.
So I think that'd be 180 plus this angle, which actually wouldn't that be at a heading of 165.4 degrees?
Wait. Oh,
No.
What do you mean? No.
It'd be more than.
Oh, sorry, did I do my arithmetic incorrectly? I meant at a heading of 180 degrees plus this thing, that would be, help me, 265.4 degrees. My apologies. I messed up that first digit.
Oh, I did my arithmetic wrong. I started at 270. I should have started at 180.
That's okay, I just made an arithmetic error too. Bradley, is that too fast?
I'm sort of getting it. I mean, I haven't taken physics or anything like that, so some of this is
Oh,
kind of
because I was gonna ask the same question today, just in higher dimensional space,
okay.
with the wind blowing down. Yeah, that's it. Can I get rid of this?